So, first of all, we would briefly discuss about the logic of confirmatory factor analysis. So here we have two simple pictures that are, I hope so, differentiating easily exploratory model, which is on the left, and confirmatory model, which is on the right. So I would briefly recap what is the meaning of exploratory factor analysis. So we are using some observed variables. So here, these are called as I1, I2, I3, and I4. So the reason is that usually we call these variables as indicators. And we are trying to inquire whether there is something behind the scene. So it means behind these four indicators. And here, as one proposal, we have two factors solution. So we have factor 1, factor 2. Both of these are inside circles. So it means they are not observed. These are latent variables. And in exploratory factor analysis, we are estimating all of these green as well as red relationships or links or coefficients. You know that we call these coefficients as factor weights or factor loadings. And according to values of these factor weights or factor loadings, we can maybe conclude that it seems that first two items are somehow related and they can create something what would be called as factor 1. And that next two items could be related and they can create maybe factor 2. If you remember our EFA example, which was based on 11 items, so first 5 items were according to our opinion measuring left and right scale. And the next 6 items, as there were some minor problems I must mention, but next 6 items were measuring something what we called as conservative liberal scale. So this is classical exploratory factor analysis. And according to our previous discussion, you can see that for all variables that are endogenous, so at least one-headed error is going inside, we have also random errors related to these. You know, according to our previous discussion, that for factors, as well as for these random errors, we would be estimating their variances. That was the rule number 1 previously discussed. In comparison to EFA, confirmatory factor analysis, or CFA only for the next discussion, we have strong assumption that first factor is based only on first 2 indicators. There is no link, as you can see, from factor 1 to item 3 and item 4. We call these cross relationships as cross loadings. So if there would be such loading, we would call it as cross loading. But in ideal CFA world, there are no such cross loadings, and every item is related to only individual and only one factor. So here, factor 1, factor 2, I1, I2, I3, I4, and there is one more added information here that it is expected that these 2 factors are related. Also for this EFA, these could be related. You know that if you rotate original solution, you can decide whether to rotate orthogonally, then there is no relationship, there is no link between factors, or you can use so-called oblique rotation, and then there would be some relationship and evaluation of this relationship, usually by correlation coefficient. So here we have 2 dimensions. First one created by I1, I2, second one I3, I4, and these 2 are expected to be related. So these are differences between EFA and CFA model. I would like to mention that EFA model is usually applied at some of the first stages of a research project. So we are developing some idea that some items are measuring one phenomenon together. That's the main goal of EFA. So it means we are, if I rephrase it by another ways, inventing some theory or some concept that is measured by individual items. So that's, I would say, the first stage of some development of some scale or measuring instrument in classical thinking in classical quantitative research measuring. If we switch into CFA, so we have at least some idea, we have at least some hypothesis, we have at least some theory that our measuring instrument is working somehow. So we have, for example, here, strong assumption that factor 1 is created by first two items, factor 2 by next two items, and that's all. And maybe that these two are related. So here we are inquiring data or exploring data, and we are preparing the instrument. And here we are using the instrument and testing the instrument as a whole. So I hope that we are still in touch. I will only check it. Yeah, it seems it works. So once again, go back. That's the difference between EFA, CFA by the picture, and between EFA and CFA in stages. So some further stages of research are usually based on CFA. If I would like to rephrase CFA by equations that are behind, so you can see very simply that there is 1, 2, 3, 4 regression equations, as we have 1, 2, 3, 4 endogenous, or here we can use also original expression dependent variables. And we have only factor 1 and factor 2 as explanatory or exogenous variables in the model. And for every equation, there is one random error which is present here. So if I switch to the next slide, so you can see first one equation is saying that y1, I1, so it means the first item here is starting and based on factor 1 and adding some random error. So here it is, I1 is some coefficient, which is called lambda, 1, 1, as it is for the first indicator from the first factor, plus the first random error called E1. For the second, it is lambda 2, 1, once again multiplied by the first factor, and plus the second random error. And you can see nearly the same logic applied for the second factor for item 3 and item 4. And our main goal is, of course, to have data. So it means variables I1, I2, I3, I4, and to estimate these lambdas. So my main goal is to estimate these relationships. And for technical reasons, mostly as in the CFA, as well as in EFA, we are using these lambdas in standardized version. So it means values in the range -1 and +1, and they are usually interpreted as correlation between original item and the factor. So these factor loadings or factor weights are usually called as lambdas, and usually we use standardized values. So we are not interested in non-standardized values. So that's about CFA model in general. And one more warning I would like to add. These pictures we went through are very, very simple. The main reason is that we can very easily describe these pictures. But for real life models, doesn't matter whether it is EFA or CFA, we would never use only 2 indicators for one factor. So for classical EFAs or CFAs, the simplest recommendation in the literature that can be found is saying that at least 3 indicators should be related to one directly measured phenomenon. So it means to one factor. So please remember that at least 3 items ideally should be related to one factor. It is possible in some special cases to have only 2 indicators, but generally, at least for one factor model, it's not possible even to evaluate such model. So please try to avoid models in which you have only 2 indicators per one factor. So that's only one more warning. And next step would be that we will try to find some CFA model for data. So we would be discussing about CFA models in JAMOVI, and we will learn also how to evaluate these CFA models in classical structural equation modeling framework. So before we start, I would only save previous step. So it means Blau-Duncan data as the first one, and I would close it. And in the next step, I would open a new one data file, which is called as CFA-WB. So these are items that are trying to measure well-being. So I would open this well-being data set. So here it is. I would need only to find this data file. So I would go into Advanced Statistics course, SEM data, and that's CFA-WB data file. So here it is. I will only save previously discussed data for path analysis and also close this file. And here we have well-being data file, which is based on 11 items, sorry, 10 items only, measuring well-being. I guess that if you click into variables, you can find some basic information that individual variables are simply described as WB underline 1 up to underline 10. And here we have the scale, which is quite a short one, from none of the time, 1 to all of the time. If you would like to know more about this scale, I would need to find original wording, but I guess we can only take it as it is. So these are classical 10 items that are expected to measure well-being. And especially here we have, once again, data from student at Tomáš Bata University in Zlín. So we should try to find whether it is possible to measure well-being by these 10 items for students' population. It would be our goal. So I would switch once again into data matrix, and we would first of all try to prepare confirmatory factor analysis for these 10 items, and then we will try to evaluate this model. I would like only to make small note about properties of these variables and about maybe possible alternative algorithms for the estimation for the structural equation models. Originally, structural equation modeling is designed for variables that are expected to be continuous or cardinal or at least long ordinal scales. At least classical estimation by maximum likelihood technique, which is usually default in statistical packages for SEM, and also the first computation, which is based usually on classical covariances or classical Pearson's correlations, is expecting that we have quite long scales or cardinal data or continuous variables. If your variables are ordinal, or in extreme, they could be as short as binary variables only, so it means variables with two only options. So if you apply classical style computation of SEM, so it means Pearson's correlations or covariances, and then estimation by maximum likelihood, usually you will get quite bad results, not as your data are not good enough, but it is only artifact of this algorithm and covariances or correlations that are not designed for ordinal data, at least for short scales. So if we would like to work properly here with this data set, which is based on only 4-item scales, we would maybe switch into some alternatives. These alternatives I would mention are usually based on alternative correlations. So instead of Pearson's correlation coefficient, we are mostly for this short scales applying so-called tetrachoric correlations. So that's one possibility how we can slightly modify the computation. And also estimation algorithm for these short scales should be changed. Usually something what is called in shortage as WV, WLS, which is weighted least squares, and sometimes also some added letters such as MB. So these algorithms such as W, L, S, MB are applied to these special occasions. But fortunately, for this data, even classical dialog, so it means classical covariance or correlation with maximum likelihood would work quite properly. So that's why we wouldn't solve this topic. Unfortunately, at least according to my knowledge, in JASP or JAMOVI, there is no special algorithms for tetrachoric correlations in SEM. Only what is possible in general SEM syntax is that we could switch into alternative algorithms for estimation. But once again, we wouldn't utilize these options. So that's why I would go into analysis. And for simplicity, so it means it's not necessary for us to define the model by equations. We would use option for factor analysis, which is present in Effector. And here the last one option is confirmatory factor analysis. Once again, alternative would be to go into SEM and SEM syntax, and we would need to recognize what is symbol for confirmatory factor analysis. So for something what is called measuring models. So it means how to measure factor 1 and factor 2 by individual indicators. If you go back into previous presentation about introduction to Laban, you know that there is 1 tilde for regression, 2 tildes for correlation or covariance, and equality sign and tilde is for factor analytic model. So if you would like choose this SEM syntax model, it is possible, but we don't need it. So I would go here directly into Effector and confirmatory factor analysis. And this is very nice graphical user interface with clicking only. So that's quite easy to define confirmatory factor analysis here model. I guess that maybe there would be problem that my variable are properly defined as ordinal, but here you can see there is only symbol for cardinal variables. So if I would move it, I would expect it wouldn't work. So you can try, but it works. So I would say, fortunately, in JAMOVI, it's not necessary to redefine properties of these variables from ordinal to scales. I know, according to my previous experience, that in JASP, in which there is nearly the same dialog, it is necessary to redefine property of these variables into cardinal or scale. So I will take individual variables to the right-hand side, so WB1 up to WB10. So first 10 indicators should be included. And you can see that by default, I didn't ask for anything. Still, some results are present here. So before we would go into these results and we would try to understand individual coefficients and tables, I would maybe go into details of these options for confirmatory factor analysis dialog. So first of all, you can see that here we have options, and you can see that there is only one option or two options. If I mention full information, that there is full information maximum likelihood. So it means that I am using all data, including also those data that have missing values. That's is usually called a shortage FIML. So that's full information maximum likelihood. And there is also alternative to take out of the analysis all cases that have at least one missing value. That's case list-wise option. Fortunately, we have full data, so there are no missing data in my data matrix. So both of these options would give the same results. But of course, if you have some missing data, these two options can assign you different results. Then there is something special for CFA model, which is constraint. We will discuss about this constraint in detail by rule number 6 later. But if you would like to apply CFA model, it's necessary to somehow set the scale for these factors, as they are totally artificial variables somewhere behind my data. And you can imagine that, for example, I can decide that factor 1 could have the average something like 10,000, could have also the average like 1, could have the average 0, -1, -10,000, or totally infinite number of values could be the average level of the factor 1, the same for factor 2. And if we would like to compute results for CFA, we need to somehow set up this scale for this factor 1 or factor 2 if we have more factors. Currently we have only one factor. And there are two possible options how we can set up the scale for factors. And here we have two simple options. There is also one more option, but we wouldn't discuss about this specialty. By default, in JAMOVI as well as in JASP, and I expect that this is also default in Lavaan. Sorry for that I do not remember default in Lavaan. But default in JASP and JAMOVI is saying that I would assign variance for this factor at the level of 1. So that's one option. I would say that this option is not very common in structural equation modeling. That's why I would propose to switch to another option, which is saying that I would assign factor 1 to the first item. So for example, here to I1. Factor 2, by this rule, would be assigned by I3. So it means that these loadings will not be estimated, but by my constraint, I would assign 1. And it means that the scale of I1 would be the same as the scale for factor 1. And the scale for I3 would be the same as scale for factor 2. So that's alternative option. And once again, I would say the most common option for constraining of factors in confirmatory factor analysis. So the scale factor, scale first indicator is a very common option. So that's why we are switching from the default here. You can only see a small difference directly in the output. If I apply this factor variance is equal to 1, so here we have different estimates for this relationship of individual indicators to the factor, but there is no of these values equal to 1. And here you can see in the next table that the variance of the factor 1 is automatically fixed. There is a small note with the letter A, which is under the table, described, fixed parameter. So this variance is not estimated, but fixed. If I switch to scale factor, scale first indicator option, here it is the result. Currently, I am estimating variance. So here, the variance is not fixed, but it is estimated. But the first link from the first indicator to the factor is fixed currently to the 1. So here it is, once again, note, it is fixed parameter. And all the rest coefficients are bigger or lower, and means bigger or stronger or weaker relationship of next indicators to factor 1 in comparison with the first indicator. So these are two options of fixing of factors, and it's necessary to somehow fix the factors to have an option to estimate CFA model. As once again, there is no original scale for factors. They are totally artificial variables somewhere behind my data. So that's it, how it works. So here it is. And once again, the scale factor is quite common option. So that's why we are using this option. So that's about options. Here we have estimates, and you can see that by default, here we are estimating factor covariances, as we have only one factor here in the first model. So we are only estimating factor variance, which is covariance of the variable with itself. So that's why we have here this table. If you would cancel this option, there will be no estimate of variance or possible covariance between factors. You can also add a description of factor intercepts, but we don't need these for this introductory lecture, so we wouldn't ask for these. Also, residuals intercepts are not necessary for us, but what would be nice for us every time would be to ask for confidence intervals. So you can see that currently here in the table for factor estimates, as well as in the table for factor loadings, there are 2 more columns for confidence intervals. And also, once again, we were discussing that mostly we are using standardized estimates. Factor loadings especially are standardized, so that's why I would ask for standardized estimate. And here is the new 1 column. In some statistical packages, there wouldn't be this unstandardized estimate column, and there would be only by default the standardized estimate column. So you can find some small differences between individual packages. So that's about estimates. And I would go to the next output possible modification. And here we have a model fit. This model fit option is, according to my opinion, quite brief. I would expect more, but still we have here CFI and TLI. These are the most common evaluation of the quality of the model. Once again, here for CFA, usually chi-square test is not appropriate to use. You can see that by default also RMSEA is applied. Once again, that's it is some measurement of known quality of the model. Mostly, we are also applying SRMR, so that's why I would ask also for this statistic. And these 4, I would say, classical golden standard for the evaluation of the quality of the model. So these 4 should be enough. And if you like to ask for something more, you have here 1 more option, which is additional output here. And here you can ask for path diagram. So we can check the picture from my model. And you can also try to find, I would say, some diagnostics for the quality or non-quality of the model. I would rephrase it by another verse. These residuals, observed correlation matrix, and modification indices could help you to somehow modify, it means change, improve the quality of the model. I wouldn't go into detail for this first insight, so I would only ask you to check option for residuals and correlation matrix. And for modification indices, I would propose to type here instead of number 3. I do not understand why there is number 3, as in nearly no literature you can find this cutoff. Mostly you can find the value 10 or 4, so I would use the bigger one, 10, and click into enter. And we would get some new outputs, and we would discuss about the meaning of these outputs in next minutes. So here we are. So currently we applied nearly all possible outputs. We can get here. The only one option here we didn't visit, and that's residual covariances, but that's not about output, that's about modification of the model, and we would visit this dialog later. So take it as it is currently, and now we can go into results. So first of all, I would go to this first table with factor loadings, and according to my opinion, the most important result is this standardized estimate column, which is somehow describing the relationship. Once again, this is nothing more than correlation coefficient between individual indicators and my factor, and I expect that my factor is measuring well-being. So if I take these values, once again, the range from -1 till +1, so I can find that maybe some items are much better. For example, number 10 has the correlation nearly 0.8. So that's quite nice item, which is the best way how we can describe well-being, I can say. The second biggest value, according to my opinion, is for item number 8, number 6, 0.772. So once again, very strong relationship. And the third one is well-being item number 8, 0.6. So these three at least are very nice and closely related to the latent unobserved variable called well-being. If I go to the bottom, so it means to the weakest indicators, so I can see that, for example, indicator number 4 and number 5 are quite weak one. 0.3 approximately are these correlations. If you go back into your previous knowledge about regression, so if you take the square for these values, 0.3 squared means 0.09. So only 9% of these indicators, so well-being 4 and 5, is influenced by latent variable measuring well-being. So that's not a very good result, I must say. So only very small variance is explained. Maybe you remember that this explained variance in factor analysis we generally call as communality. So here the level of this communality is very low one, but uniqueness, so it means something, well, this item is not sharing with all the rest is very big, more than 90%. So these variables are quite unique, and maybe, and it could be modification of my model, I could omit these two items from my confirmatory factor analysis, or from this, we would call it in other words, measurement model. So we are trying to prepare model for measuring well-being. So once again, these two items are quite big one, as I can recognize by the standardized estimate. Some more information in the next columns are discussing 95% confidence interval. Unfortunately, but don't ask me why, this is the same in JESP as well as in JAMOVI. This is not a 95% confidence interval for these factor loadings, these standardized values, but for these unstandardized values in the first column. So this is slightly useless according to my opinion. And here we have also formal statistical test. So it means if you take the estimate and divide by its standard error, you would get test statistic, which is called Z. And it is evaluated by p-value. And it is saying that none of these indicators is unrelated to well-being latent variable. All of these links seems statistically significant. So that's about these p-values and related tests that are present here in Z column. So that's about the meaning of this confirmatory factor analysis table. And once again, the most important results are especially in this standardized estimate. And once again, we have here maybe some doubts about two items, number 4 and number 5, as loadings for these items is quite big one. If I go down, so I guess that somewhere at the end, you can find the picture as path diagram. Unfortunately, and that's by default, and there is no option to change it, there are no values here present. And here you can see only dashed line for coefficient which is not estimated. Once again, we decided that we would fix this coefficient to 1, and that's why here we have a dashed line. All the rest coefficients are estimated. That's why we have here a solid line in the picture. And once again, unfortunately, this picture is quite nice, but there are no information and there is no option to change it in the picture about the size of these coefficients. So that's why it's slightly useless, according to my opinion. If you would switch into classical SEM syntax model and you would define model by equations, of course, you can get the picture with coefficients in standardized or unstandardized version, as you know from previous discussion about path analysis. But we would not switch to this analysis for today, maybe next week. And I would go back to next results that are present here. So here we have also the information about the variance for my factor. Of course, if I standardize my solution, it must be that standardized variance must be 1. So that's by default. And there is also formal test that the variance of the factor is not 0. So here we have Z test criteria and p-value, but it's nearly useless, mostly in structural equation modeling framework, so we do not need to discuss it. Here we have formal chi-square test, which has 167 units, and once again, distribution behind is approximately chi-square, 35 degrees of freedom. Maybe we should understand why we have 35 degrees of freedom here. So if I go back to the picture, originally I have 10 items, and if I have 10 items, I would be able to compute k multiplied by k plus 1 divided by 2 individual variances and covariances. So if I'm multiplying in my head, it is 10 times 11 divided by 2. So 5 times 11, and that's 55. So from 10 variables, I can compute 55 variances and covariances. 10 variances and 45 covariances. If you do not believe, let's go into math from secondary school and check it. And from these 55 possible sources of information, I will try to evaluate these individual relationships. Only the first one is fixed, so I have 9. Then I would be estimating individual variances of these random errors. They are not present here in the picture, sorry for that. And I would be also evaluating 1 variance for the factor. So if I sum up 9 plus 1 plus 10, so it's equal to 20, and 55 original sources of information and 20 estimated parameters. So 55 minus 20 is equal to 35. So it's correct computation of degrees of freedom here in JAMOVI. And here we have the evaluation of chi-square test. You know that this chi-square test is based on null hypothesis, which is saying, okay, my model is good, my model fits to my data, or in more technical stuff, my covariance matrix in my data is nearly the same as covariance matrix which is generated by my model. So model and data fits together in other words. And here you can see small p-value, but once again, there is no need to be said that we would reject my model, as once again, for CFA and more complex models, nearly every time this test is too strict and would reject null hypothesis. That's why we would switch into alternatives. And here we have these alternatives in the next table, which is called fit measures. And here we have measuring of the quality of the model, CFI, TLI, the most common, and also SRMR and RMSEA, measuring error of the model. So once again, simple recommendations for CFI's TLSI is at least to have 0.9. So for both of these, it is quite sad story here that my model is maybe not quality enough. And SRMR should be below 0.05, so we are somewhere on the border. And RMSEA should be at least below 0.08, slightly above. So according to most of these fit measures, once again, these are quality and these are non-quality measures. It seems that my model is not the best one. And we know about some problems for my model. At least we know that item number 4 and 5 are quite big one. So maybe it would help if we would take these items outside of my model. Maybe it would improve result. And we would also discuss about some other options, how we can recognize some problems in my model. Next one, output, and this is the output which was called here as residuals observed correlation matrix, is present here. So here it is, and it is including figures that are measuring discrepancy, so it means difference between covariances or correlations, here correlations, that are present in my data. So it means I would compute correlations for my 10 variables. And then I would compute correlations that are based on my model. So it means one factor based on these 10 items. And this is the difference between these two correlations. The ideal would be that these correlations, here is only upper triangle of correlation matrix. So ideal would be that these values would be 0 or close to 0. And here we have recommendation, and that's quite good recommendation, that values above 0.1 are problematic and maybe means that there is some problem inside my model. So you can see that, for example, here, relationship for well-being 4 and well-being 5 is somehow incorrectly modeled as this residual. So it means difference between correlation from my model and my data is not the same. There is also some more problem. Well-being 3, well-being 4 correlation is underestimated and should be bigger. And there are some more problems here, well-being 2, well-being 5, well-being 3, well-being 5, and also here, well-being 2, well-being 9. So maybe that some items, that's my conclusion from this table, have something in common, and they do not share these common properties with all the rest variables. The biggest relationship, which is underestimated by my model, seems to be here, item number 3 and item number 4. So maybe that I would somehow include this relationship into my model, one option, or maybe second option, that I would exclude well-being 4, well-being 3 from my model, and it should help. So these are conclusions based on this residuals for observed correlation matrix. And once again, big values means that something is usually missing in my model, that I would need something more to include into my model. And maybe now you can ask yourself, what could be added to my model if I have model that is including 10 items and all links to all these items to factor 1 is included. So if I would like to take into account that maybe 2 or more items have something in common, but they do not share this property with all the rest, the option is very simple. So if I go back to this picture, as random arrows are not present here, so that's why I would go to this picture. So if some items are showing something together, but they are not showing the same phenomenon with all the rest, the possible solution is that I would take these random arrows for these 2 items and I would make connection. Here, it doesn't make any sense as I have only 2 items for the factor. But here, if I have, for example, item number 3 and 4, and they have something in common according to previous discussion. So if I would have here random arrows, I would make correlation or covariance for these random arrows. And maybe it would improve the quality of my model, as I would admit, okay, these 2 items share something together by latent factor with all the rest, but they have also something in common only by this pair of variables. So this is possible to how we can improve the model and still keep the number of items. So I wouldn't omit any item from my solution. So here it is, how it works, and I would add one more output that could help us to understand to these results. Here it is. This is the next one, last one table, which is called Modification Indices. This table is taking values of chi-squares and is saying, okay, if you would add something into your model, what would be decrease of your chi-square? Once again, chi-square test originally is 167 units. If I would decrease chi-square, it means that maybe p-value would be bigger. And it means that also the CFIs, TLSIs, etc. would have a better quality. So here is some proposal of modification indices. If I take this big table, and once again, I decided here to highlight values above 10. So that's why only values above 10 are highlighted by red color by default. So I can see that, for example, the biggest value is 44 approximately. And it means if I would add to my model relationship for random error well-being 3 and random error well-being 4, my chi-square would decrease from 167 to approximately 120 by 43 units. So these modification indices is, according to my opinion, quite nice tool that could be applied to improving the model by inclusion of some more parameters into the model. So I would decrease chi-square quite a lot. It would be decreased by approximately 1/4 if I take a relative value. And of course, it would mean that also degrees of freedom, unfortunately, would decrease by 1. So I would have only 34 degrees of freedom. So that's only the second phenomenon, which would be related to this edit parameter. If I go back, I can also decide to add other options. So it means other covariances between random errors, but no one is so strong as this one. So it means random errors related to the third and the fourth item. If I use these modification indices, the next step would be, okay, I know that this would help to the quality of my model. And next step would be to recognize, it means substantively evaluate whether I should include some new coefficient to my model. So currently, my goal would be to read item number 3 and number 4 and to recognize whether they have some same property that is shared only by these 2 items, but not shared by the rest. So currently I would go into original questionnaire and evaluate whether well-being 3 and well-being 4 share some contents that should be included into my model. We wouldn't go into this step, but I can say that if I remember well, discussion about this well-being scale with my colleague Jitka Vaculikova from Tomáš Bati University in Zlín, and we discussed about this relationship, and Jitka decided, okay, it seems to me that these 2 items should be related by the random errors. So that's why we would take this recommendation from modification indices, and we would apply some small change in the model. If this wouldn't be the case, so it means from substantive point of view, it makes no sense to add this link, I would go to the second biggest modification index, which is, according to my opinion here, well-being 10 and well-being 7, I guess, and I would recognize whether this improvement should be made. Once again, it shouldn't be automatically added to the model, but I should evaluate it substantively. So here I would add a relationship between random error for well-being 3 and 4, and we would check results. So for possibility to compare results, I would propose that we would prepare a new one, confirmatory factor analysis. So I would once again ask for factor analysis, confirmatory factor analysis. I would once again move well-being variables into the model. So 10 items. We know that for options, we decided to scale factors according to the first indicators. So that's it. For estimates, we asked only for confidence interval and standardized estimate. Then we asked for additional output, so it means residuals and modification indices. And you can also ask, and it will be surprise for me, for a path diagram for this model. And if you would like to modify our previous model, so we would need to visit residual covariances. And here, if we would like to make a link between 2 random errors, it's necessary, it's not fully logic, to take these 2 items, so well-being 3, well-being 4. It needs to take control key into action and move it to the right. And if you move this pair, So I guess that you should find some modification in the model. And here the chi-square is currently 122. So decreased by approximately 43 units. Once again, originally it was 167. And promise, according to modification indices, were decreased by 44 units. If you take 167 minus 44, so it seems to me it is correct computation that currently it is 122. So currently our model is modified. I will check whether this modification can be seen from the picture. Unfortunately not, sorry for that. But here should be the link. But it's not implemented in JAMOVI properly. So sorry for that. So we can recognize it only in the menu that in residual covariances there is a pair well-being 3, well-being 4. And once again, we can check the values of BIC residuals for correlations and also for modification indices. If you go into these values, so at least the modification indices are much lower than previous one. The biggest value currently is nearly 18 here for well-being 2 and well-being 5. And if you go back to the overall evaluation of the model, so once again, we have 34 degrees of freedom, still very small p-value, but once again, chi-square test is useless for these models usually. But if you see CFI, TLI, RMSEA, and we also could ask for SRMR. So I would ask also for SRMR here. So you can see that all of these values, or nearly all of the values, are quite nice. CFI 0.92, SRMR approximately 0.05, but slightly below. RMSEA slightly below 0.08. And only TLI is slightly below 0.9, but please don't be totally precise. This is nearly 0.9, so it's still good quality of the model, according to my opinion. So according to this evaluation, there is maybe no need to change the model. And I would say that this model could be applied to well-being. Once again, the only one modification we added to the model is that we take the relationship for residual terms for the third and the fourth item. So that's only slight modification, but still we are using all 10 items into my model. If you would use this SEM syntax mode, this link for these two residual errors would be typed as WB underline 3 and then double tilde, as it is covariance or correlation, WB4. That's only how it works in SEM syntax model. And if you can evaluate this model, so this model seems quite good, and there is maybe no need for further modifications. So it would be my conclusion, and I would take this model as it is. If you are Czech students, so you can consult details of this model in the newly published textbook in which the same model for well-being is applied. So that's about this well-being case, or I would say about one factor solution. So currently we applied one factor solution. And if you would like to see more results, so I guess that if I click into estimates and I would ask here for residual covariances, so I guess that we can find the relationship for well-being 3 and well-being 4 here in one column. So you can find that the relationship, so it means standardized estimate correlation, is 0.3 for these two items. So that's quite big correlation, and that's why it should be implemented in the model. So that's also how we can evaluate this relationship directly by values. So that's it, and that's how we can modify CFA model. I would go back into the presentation, and we can go very quickly through slides we were discussing. So that's it, and only one more comment I would add. And let's comment about so-called AICs and BICs, so-called information criteria. For complex models, not only structural equation models, for complex models and statistics, sometimes, sorry for that, we apply these information criteria for comparison of different models. What is the meaning of these information criteria? They are measuring the quality of the model, usually by likelihood function, and also complexity of the model by number of parameters. And we usually try to find the model which is the simplest, but the best one according to the overall quality measured by likelihood function. And that's why these AICs or BICs are combining complexity as well as quality of the model into one figure. And usually they are designed the lower, the better. Here you have some recommendations for BIC. The difference, at least 5, is quite good. And if you go back to our previous discussion, we can go back to our first model. So here it is. And we can ask for these AICs and BICs as additional outputs. So if I go down to fit measures table, so here we have AIC and BIC. Maybe I would make a copy of this table. And I would take it outside, for example, here in Microsoft Word document. So this is my original model. So I will type it here. That's my original model. And I can compare with the next one model. So it means model which we are computing by adding of link for certain false random error. So here it is. And here we have AIC and BIC table. So I would once again make a copy. So that's modified model. Here it is. And here we have these AICs and BICs. I will use, for example, red color to see AICs. And maybe blue one for BICs, as of course we must compare the same figures, so AICs and BICs, but not across these two. And once again, recommendation is that lower value is better model. So for AIC, you can see the difference approximately 43 units. And nearly the same value should be for BIC. So if we make one modification, this change of AIC and BIC should be nearly the same as the change for chi-square. And you remember that chi-square's change was approximately 43 units. And decrease of 43 units for BIC is much bigger than proposal at least 5. Or sometimes it is discussed that 10 lower BIC is definitely better model. So it means, according to these BICs comparisons, that the second model we have just applied is much better than the previous one. And also the same rule could be applied to AIC. And once again, the story is the same. So according to these information criteria, we can compare different models. And here it seems that the second model is much better than previous one. That's why we would apply the second one model. So that's evaluation of the model by information criteria. So here it is, and we finished the discussion of CFA model. For this first insight, we discussed about modification indices. That's why we can change, we can skip it. And I would try to make a brief conclusion for this first insight into CFA by 3 new rules, which are mainly designed for confirmatory factor analysis. First one rule, sorry for mistype, I will change it. Rule number 4 is saying that all factor loadings are estimated, but theory can expect that some loadings are not estimated. So for example, here for my model, I am estimating all possible loadings. Only the first one is fixed, but we will discuss about this fixed thing later also. But for example, here for my picture in the presentation, once again go back. So I'm not estimating these cross loadings as theory is not expecting. So mostly if I have more than one factor, it's not true that all factor loadings are estimated. So here it is. This rule usually has quite a lot of exceptions. Here is a note that the expectation about theory is quite common in classical CFA models. So that's rule number 4. Rule number 5 is saying that variances and covariances between endogenous variables and covariances between exogenous and endogenous variables are never estimated. So if I go back to my model, it means that I am not able to make correlation or covariance for these endogenous variables or these manifest endogenous variables. So no possible correlation here. But if I add here, and once again, it's a pity it's not present in JAMOVI, random errors. So these random errors are exogenous and they can be linked by covariance as we did in the previous step. So for endogenous variables, there is no option for covariances. And there is also no option for estimating the variances. We are only estimating variances of these random errors that are linked to individual endogenous variables. And the last one rule we discussed about it, for every latent variable, especially for factors, we need to assign the scale. One option is, we know about it, to take this link for the first indicator as number 1. Alternative is to somehow assign the scale for factor by fixing the variance usually also to 1. But you can decide also about another level. If you would decide that this value would be 2, so it means that factor would be 2 times this well-being number 1, etc., etc. So usually fixing to 1 for this length or for the variance, that's classical option. That's it. And JASP and JAMOVI is using as default fixing of variance. If you like to change it, we know that we need to go into options and here change constraints. And after first one practice of CFA of one factor only model, I would go into second option for one factor model. So we would open Efa ISSP 99 data currently. And first of all, we will try to test one factor model for first 5 items that could be measuring left-right scale. So first of all, I will open data for ISSP 99. So here it is. So I would once again need to find the data file. Here it is. It is called ISSP Efa SAV, as we also applied Efa to this data for simplicity. You can see the data matrix is including 11 items A47A up to A47K, and then some added values voted LR scale and gender, and also identification in the first step. And first goal would be for us to take first 2 columns, first 5 columns, A47A to A47E, and apply confirmatory factor analysis to this set. So I would go into factor, confirmatory factor analysis, and I would take first 5 items. Here it is. And I will only slightly change options. So once again, I will change constraint for fixing factor by first indicator. And I would ask for confidence interval and standardized estimates. And I would ask for model fit to see also SRMR. We will not compare some models, so there is no need for AIC and BIC, and we will try to evaluate the model. So here it is. You can see, at least by standardized estimates, that these values are quite nice, but still the first item is quite poor in comparison with all the rest. So its standardized estimate or factor loading is slightly below 0.5. For all the rest, it is approximately 0.6 or bigger. But still, it is much better than previous. So it seems that these 5 items could be linked together. So it seems that this model for these 5 items would work. And we can go down for all the rest. You can see that chi-square is 81 with 5 degrees of freedom, small p-value, but that's no big surprise. But if you try to evaluate CFI and TLI, and also SRMR, RMSEA, so all these seems quite good. Only RMSEA is slightly above the proposed threshold, which is usually 0.08, but it's not too big. So I would maybe accept this model for the first insight. Now I would stop sharing and discussing for a minute, and I would ask you if you can try to prepare the model for the rest. So it means the next 6 items, so A47F to A47K. It is expected they are measuring liberal conservative scale, and try to apply this one-factor model, and we would evaluate it, and then we would continue by combination of all 11 items into one complex model. So I would stop sharing and pause recording for a minute. And what's your evaluation of the model for liberal conservative scale? Is it appropriate or not?
It is appropriate.
It seems quite good, in spite of the fact that if you check factor loadings, so it means standardized estimates of these, so some of these items are quite big one, especially A47I has the loading 0.225, which is quite low one. Also for A47J, it's not fantastic, and maybe also for A47G. But still, if you take all of these together and you take fit measures, CFI and TLI quite good, SRMR quite small one, and also RMSEA is quite low one. So it seems also this model could be applied. Once again, we need to add warning that we know that some items are quite poor, and maybe if they would be omitted from the solution, so it means from this measuring instrument, it would help us. So still, we would like to follow original measuring instrument, so to take 5 items for left, right, and 6 for conservative and liberal scale. So we will take all of these. And after these, I would say 2 preliminary steps. So it means we somehow try to evaluate one-factor model for left-right, one-factor model for conservative liberal scale. I would like to take both of these and prepare 2-factor model for left-right scale and conservative liberal scale. So it means to take all of these 11 items, and we would be testing 2 competing models. Today we will finish only first one for both of these, but next one we will continue this discussion. And our 2 possible models would be that liberal conservative scale and left-right scale could be uncorrelated, so there is no relationship at all expected, one model. And the second model would be that these 2 could be correlated. And my final goal would be to decide which model is better to my data. Unfortunately, JAMOVI, or dialog for confirmatory factor analysis in JAMOVI, will give us only results for related factors by default, and there is no option to change it. So next time, if we would like to see uncorrelated factors, we would need to go into SEM and to add one more constraint that 2 factors are not related at all. In JASP, for example, there is a special option by which directly in this CFA dialog you can ask for uncorrelated factors, but according to my opinion, there is no such option in JAMOVI. So in JAMOVI, we would need to switch next time into SEM syntax. So I would once again ask for factor, confirmatory factor analysis. And here we need to define 2 factors. So first 5 items would be factor 1, If you like to change the name of the factor, it's possible here. So you can change factor 1 and you can type, for example, LR as left-right scale. And for the second factor, you need to click into Add New Factor. You can once again change the name if you like. So liberal conservative. So I would call it LC. And we need to define the rest of the items. So A47F would be moved up to A47K. So here it is. K must be moved as well. Sorry for that. So currently, full model is present in my data. And I would only slightly change some outputs. So for options, I would ask once again for scaling factor scale first indicator. For estimates, I would ask for confidence interval and standardized estimate. And for additional output, you can ask, if you like, to ask for residuals, observed correlation matrix, and modification indices, but we do not discuss. I will only ask for path diagram for this insight. And for model fit, I would ask for SRMR as well as AIC and BIC, as we will compare this model to the next down model next week. And here it is. So here we have our outputs. And once again, we can very simply confirm that the first set, measuring left-right scale, is much better, as the standardized estimates of factor loadings are much bigger than for liberal conservative scale. If you remember results for exploratory factor analysis for the same data, it was nearly the same picture. So measuring of left-right scale in check conditions is much better than measuring of liberal conservative by this set of items. So that's my first conclusion. Next should be related to the evaluation of the overall model fit. So chi-square 297 with 43 degrees of freedom. P-value is very, very low one, but that's not a big surprise. Once again, quite complex model. So we wouldn't interpret this non-satisfactory value of model fit, but we would go into fit measures. And you can see that CFI and TLI are quite nice. And also measuring of misfit by SRMR and RMSEA is also quite nice. So according to this overall evaluation, this model is quite good. Here you can see the picture. So the picture is saying I have left, right, and liberal conservative scale, 5 and 6 items. There is also expected relationship. And my last question related to the model, which we will try to answer, is what could be the relationship? So it means what is the strength of this relationship? Ideally, we would use for the evaluation correlation coefficient. And if you like to know this correlation or level of this correlation, we would go up to the table which is related to factor covariances, so factor estimates, factor covariances. And for the second row, you can find the relationship for LR and LC. So here it is, unstandardized coefficient, so it's covariance. But here in the last column, there is correlation, and it is approximately 0.6. So it is saying that the relationship between left-right and liberal conservative in the Czech environment, once again, these data are approximately 20 years old, is very strong one, 0.6. And as original items measuring left-right were as low value is left and big value is on the right. And for liberal conservative, it was low value is conservative and big value is liberal. So it means that this strong relationship, according to our computation, approximately 0.6 correlation coefficient, means that for Czech case 20 years ago, it was valid that those on the left were mostly conservative and those on the right were mostly liberal. So it was the orientation of this correlation according to the meaning of original scales for individual items. So that's the conclusion. And maybe if you remember our previous discussion related to EFA, we also found that it is much better to take oblique rotation instead of orthogonal one, as correlation in EFA was also quite strong. But if I remember well, it wasn't so strong enough, as currently the CFA model is slightly different. We are measuring LR only by these 5 items. In EFA, we would also take into account these cross loadings. So that's the difference, and that's why also correlation coefficient from CFA is different from EFA case. I would conclude that this correlation here currently for CFA is pure correlation for these two concepts, as we do not take into account for LR items for liberal conservative scale, and opposite is also true. So I would believe into this value approximately, once again, 0.6, which is very strong relationship, and I guess we cannot omit this relationship. And next week, we would discuss about nearly the same model, only we would cancel or omit this correlation, so there would be no link between left-right and liberal conservative, and it is expected, I hope so, that the quality of this model would be much worse. So it seems to me that this current model would be the winner in the competition, whether these two concepts should be related or not. But that's only assumption, and we will check it next time. Once again, we would need only to switch into SEM syntax model as a CFA dialog in JAMOVI. Unfortunately, it's not including the option by which we can take factors as uncorrelated. I will check it only quickly, but I guess that I wasn't able to find it. Here it's not present. In option, there is no option. For estimates, there is also no such option. And for model fit, there is no such option. So it seems to me there is no such option. It's a pity. Maybe if you like, you can type into JAMOVI forum that it would be nice to add this property to CFA dialog. So that's all for this introduction into CFA for today. I would like to thank you for your attention. Next week, we will finish our discussion about this two-factor model. And then the rest of next lecture will be devoted to slightly complex topics in confirmatory factor analysis model. We will learn how we can compare models for different groups, and we will learn also how we can apply CFA